Welcome, everyone. Thank you for joining us today for our webinar dedicated to OpenRAG. We've got an exciting agenda lined up. We'll kick things with a live demo of OpenRAG in action. Then we'll walk through how to move our RAG from prototype to production. Next, we'll dive into a common challenge, RAG hallucinations. We'll explore privacy and security in OpenRAG. Then we'll look at scalability and integration. After that, we'll take you on a quick GitHub repo walkthrough to highlight how you can get started. And finally, we'll open the floor for a Q&A session to address your questions. So here's the team. Thank you, everyone. You can see everyone here: Andrzej, Ahmad, Lydia, Matteo, Anne, Paul. Thank you for being here. And first, to start, I'll show you a quick demo of OpenRAG. So here you can see the interface for OpenRAG, and we'll ask a very simple question first. We'll ask, what are the benefits of RAG technology? So we're searching for relevant documents, and you can see that RAG allows to address outdated information, to enhance reliability and transparency, to improve accuracy and quality, to have better handling of complex queries, reduce dependency, enhance user experience, etc. And what you can see here is that everything from this answer is coming from a video. So here the RAG was able to read the video, to fetch the content, and to make it available from a very easy prompt query. So next, we'll switch partition and we'll go to the HR partition and we'll ask, what is Laura's job? Oops. So imagine that this partition is dedicated to HR documents. And you can see that the RAG was able to say that Laura is an AI developer, and you can see where the information was fetched from our resume within the RAG partition. You can ask many questions. For instance, on which project was she assigned in June? And here you can see that the RAG was able to say that she was assigned to Gray project from a meeting minutes document that was within the partition. You can ask many, many questions. Another one here. Who is a machine learning engineer? So the RAG is able to make a comprehensive answer and to fetch every resume that's for every person that is a machine learning engineer. And you can see that everything is synthesized within a single answer. Next, we'll move to another partition. And we'll ask again, what is Laura's job? The RAG is searching, and it's unable to answer because in this partition, Laura's resume is not available. So we'll ask a question that is relevant to this partition here. So how much has been invested in AI in Europe, China, and the USA? And the RAG is able to answer $20 billion, $10 billion, and $2 billion. And you can see that this information was fetched from a PDF document and from a graphical information. So here you can see that the actual numbers are not written. It was able to read the bar charts and to provide the answer. So that's it for the quick demonstration. And now I leave the floor to Andrzej.
For a nice demo. Now I will walk you through some technical parts of our OpenRAG and show you how we tame the most failure points and how we can try to combat the hallucination, because yes, there is still hallucination in RAGs. Maybe, I don't know why it's not working. Yeah, so to start with, let's give you a quick reminder on RAG paradigm. So you know that going with LLM in production is not really possible. That's why here in the industry, we developed the RAG pipeline, which stands for Retrieval-Augmented Generation, and really to cope with the problem of hallucination. Because you know that the really difficulty of having Gen AI in production is the problem of hallucination. Basically, the LLMs always give you the answer that might look like really plausible, but is completely wrong. So it means that you experience hallucination. And how we can tackle this kind of problems. So basically, in RAG, you have two pipelines. So you have the offline mode. So in fact, you start with your documents. You try to create like a knowledge model or the knowledge database that is going to be used during the interaction, during the online mode, the interaction with the users. So here you have a query process. You have the user that asks the question. And then obviously you have like some technical stuff going on under the hood. It's the embedder. Then you search the most similar chunks of documents in your vector store. You retrieve them, you re-rank them, you feed into the LLM, and you ask LLM to generate the answer. But first of all, scaling RAG from proof of concept into production. So you come up with the multimodal RAG idea, you build a prototype within a couple of days, and you think it's an end of the story. But going into production is much more than that. It requires a lot of effort and time. So basically, building production-ready RAG, it means that you should do the production-grade REST APIs. You should create the modular architecture. You should think about data security and privacy, and also about scalability, because once your RAG system in production for the enterprise, it's gonna use the documents across the company. So it might be like many 100,000 or even millions of documents. You need to have both vertical and horizontal scalability, both for indexing pipeline, for the storage, so the vector DB, and also to be able to handle generation load. So once in the offline mode, you should be able to handle generations of sometimes 100 or even 1,000 of users connecting and using your RAG simultaneously. And what is more, obviously, every system that runs in production should have a very stable and good monitoring and logging system. And again, something that is really important is the evaluation. So this is really challenging, and a lot of people forget about it. And you know that going with the system that are highly non-deterministic in nature into production, you have to have really a very good evaluation pipeline. And last but not least, something that might ease the job is the integration with the existing system across your organization. So now speaking about the RAG hallucination, here you see that there is a lot of failure points and a lot of spots where something can go wrong. because the RAG system as a pipeline is quite advanced, and it's a chain of different models. Most of them are Gen AI models, and really on every stage something can go wrong. So here I marked some failure points, possible failure points that that can occur in both the indexation process and also the query process, and it will really impact the overall quality of your system. So to start with, let's say first is the on the level of user interaction. So basically, the user can ask the ambiguous question. So this is just from the very beginning. So even though you have like the best knowledge model, the best and most powerful LLM in the system, and you use state-of-the-art bricks along the pipeline, if there is an ambiguity in the user query, yeah, you cannot hope to get like the good answer. It's most probably it's gonna be guess. The LLM model or the whole pipeline will fill the gaps, and most probably the answer is gonna be off the topic or something that was not really hoped from the user perspective. Another point is the knowledge model. This is like the core of the whole system. So here, basically, what is really important, and you see what can go really wrong, is on the level during the indexation process, on the level of information retrieval, the enrichment, the chunking, embedding, and re-ranking. So this is something what I would classify as a poor relevance of retrieved documents, and I will explain later what I mean by that. And the third part is obviously the last part of the whole pipeline is the LLM part. So the LLM generation. So even though the LLM gets all those information extracted correctly that are really useful and relevant for the user query, it still can hallucinate or can give you the answer of low quality because you simply over-relied on generation. So now let's break down and start with the first failure points. It's about the user interaction and ambiguous user query. I will try to explain you how at this very first stage of the whole pipeline, the OpenRAG pipeline, how we try to tackle and solve this this problem or this failure points. So our proposed solution, first one is the contextualization, because you see if the user query is quite ambiguous, we try to contextualize. Maybe checking the history of the chat, and it gives us the hints what user really asked for. And the second part is obviously the well-known mechanism that is called multi-query retrieval. So basically, given a user query, you generate multiple queries, hoping that searching for the similarity of those queries in your vector DB or in your data model, you're gonna retrieve most relevant chunks for the question. And last but not least is the mechanism that we also developed in our OpenRAG pipeline, which is called HIDE, and it stands for hyperdocument embedding. So basically, it's well known that there is a difficulty or the flow between I mean, when we calculate the semantic similarity between the question that was asked by the user and the chunks, so the chunks of documents that are stored in the system, because somehow you calculate the semantic similarity between the question and answer. And obviously, the semantic similarity is not the same as the relevance. So it means that you might retrieve the documents that are not relevant to answer the question. I mean, to explain you really like in a most degenerate case, if among the chunks you have the chunk that that contains exactly the question that was asked by the user, the semantic similarity is going to be equal 1. But feeding this question into the system, into the LLM, asking to give the answer, is not going to help at all. It will force the LLM model just to use its prior knowledge, because there is no information in the same question that was asked by the user. And the Heidi mechanism somehow tries to calculate the semantic similarity between the answer and answer. So basically, given the query of the user, we ask the LLM model to give some answer, hypothetical answer, based on its prior knowledge, and then we search the semantically similar documents from that are similar between this answer given by the model and the chunks that are stored in the system. So even though this answer is like a pure hallucination, still you might have a better chance to get the right documents that you will feed into the system. Now, the second part is the poor relevance of retrieved documents. So this is really like a core of the whole system, because this is about the knowledge model. And what can go wrong here? So at the first stage, during the indexation process, you need to process different documents of different types. So what we propose in our solution, first, we develop the specific pipelines for different documents and different types. We use the advanced techniques of OCR and image captioning for visual to be searchable, because the information might be hidden or might be embedded into the visuals, so like the graphs or maybe images. And because our main philosophy is garbage in, garbage out. So even though you have the most powerful LLM system and you do really a great job at the very beginning, but you are quite or you fail on this part, the overall quality of your system is going to be quite poor. Third thing is context injection or contextualized summary. So in fact, we want to guide the retrieval more intelligently, and instead of just chunking and injecting the raw chunks into your system, we contextualize them. So we add the summary of like the previous chunks. We give the information about the name of the documents, maybe some metadata of the documents, and the summary, let's say, of the first chunk, so that you feed into the chunk much more than just the content of itself, hoping that you guide more intelligently the retrieval part. And finally, we developed and we propose in our system the different chunking strategies, because as you all know, most of people just use the static chunking strategy, and it's not quite intelligent. You can do much better. We will show that that basically using the markdown chunking strategy or maybe semantic chunking, everything is coded in our system. You can do much better job. So now, speaking about the pipelines and the different pipelines for different types of documents, as you see here, we have developed the specific pipelines for different type of documents, whether it's a PDF or the image or maybe an audio file or just the plain text. We use different pipelines to enrich the documents and to retrieve as much as possible the information that is going to be stored in the system. So for the PDF files, obviously we use the advanced techniques, and we use open source solutions like doclink or marker that is able to do the layout analysis. We couple it with the advanced vision language model or OCR systems. We are able to detect table structures. We assemble everything, and we create the enriched markdown file. The same for the images. Images, obviously, they exist in the PDF files, so it's just a part of the pipeline that we developed above. For the audio, so different audio files, we are using the speech-to-text technology, and then we do the embedding, chunking, and vectorization. And for the flat files, this is quite straightforward. We also developed the specific pipelines for other types of files, and this is still a work in progress. So we are invite you to take a look into our repo and maybe collaborate and help us to develop more pipelines for more different for different types of files. And once we have all that, basically everything we store in the file that is markdown. So it's like a generic transformation and the generic file that we used then to inject all the information into the vector store. So we call it enriched markdown document because, as you see, so starting from the PDF, we do not only parse and get the text, but we also have the descriptions of visuals, of graphs. We can also treat the audio files, and we create like enriched markdown file that is gonna be chunked and injected into the vector store. And then the last part, obviously, is the indexation part. So we do intelligently the chunking, and we store in the vector store. And when we speak about the models that or the system that should run into production, something what is really very important is the part, the scalability. So that's why our OpenRAG runs on Ray. Ray is an open source framework for scalability. And that's why, because you know those pipelines are really heavy in terms of computational cost. And this is the part, like a preparation part, because when you plug your system, your RAG system into production, first, what you're gonna do, you're gonna retrieve a couple hundreds or even millions of documents. And this is gonna take, if you don't scale it properly, it's gonna take weeks or even months. Now, continuing with the poor relevance of retrieved documents. So basically, yeah, I explained what are our solution for the part of chunking information retrieval, how we leverage the advanced visual language models, and how we do the layout analysis or treat audio files. But it's not enough. Then you see in the pipeline of RAG, you have the embedder and you have re-ranker. So embedder, it is used to create the vectorized representation of your chunks, of your documents that gonna contain the semantic information of the chunks. And then re-ranker, this is something what industry tells us that is extremely important. It is used because we all know that semantic similarity is not the same as the relevance. That's why you have a special model that is trained to do the re-ranking, hoping that you get the most relevant documents at the very beginning. So basically, while developing our OpenRAG system, we ran a lot of experiments. And we were at the search of finding the best couple of embedder and re-rankers. So here is just a part of our story. You see here on the in this table on the left, you have different embedders, like a state-of-the-art embedders from Hugging Face, and you have also the state-of-the-art re-rankers. And we calculate different metrics because we wanted to find the couple of embedder and re-ranker that works best for the given data. As you see, obviously, it's really closely related with the data types, so that we think that this kind of exercise, this kind of experimentation, you need to do with your own data once you inject into the system. But the whole pipeline is ready, and you can use it right out of the box from our repo. Now, speaking about the last part and the last types of flows or failure points is the part of LLM, so the part of generation. And the main problem is the over-reliance on generation. So, you know, even if you inject into the prompt the most relevant part and the data that should be used to answer the question, the LLM might still give you the hallucination, so the answer that is completely wrong, even though plausible. Why is that? Because LLM might use its prior knowledge, or if you feed a lot of information into the prompt, like let's say the chunks are too big or too many, and there is a lot of information that is simply not useful to answer the question. It's like finding the needle in a haystack. So the LLM might have a tough time to use or to find the most important information within the chunks that are fed in the prompt and to give you the correct answer. So here, one of the really like straightforward solution is the prompt engineering. So you really need to work hard on the prompt to somehow force and convince the LLM model that is gonna rely only on the information that is used or that is injected in the prompt, and should not most probably use its prior knowledge. And another part, this is work in progress, it's the LLM fine-tuning. But guess what? Most people propose to do the fine-tuning even for your LLMs in the RAG system, but the fine-tuning on your data, so hoping that the model will somehow learn the data a little bit by heart and will generate the better answer. I think it's a wrong path, and because the problem is that you never know whether LLM during creation or when it answers the question, whether it used the knowledge or its prior knowledge that he or the model saw during the training, or used the information that was fed into the prompt directly from the chunks. But the good news is, based on the recent publications, so the research from people from Microsoft, this is the paper, so quantifying reliance on external information over parametric knowledge during retrieval-augmented generation using mechanistic analysis. The good point is that the LLMs has a bias towards using the retrieved context to answer the questions instead of its prior knowledge. And it means that we should, in this whole paradigm, the RAG paradigm, really to be able to tame the hallucination, we need to use LLM really as just a conversational agent that is able to understand our question, and we can interact with the system just using our natural language, but it should not rely on its prior knowledge. It should only use the knowledge that is used or is injected into the prompt during through this RAG pipeline. And so what I mean by here, like LLM fine-tuning, is not fine-tuning the LLM based on the specific data of, let's say, within your organization, hoping that the system will, or LLM will just memorize the content, but fine-tuning the model to answer correctly to answer the questions based on the information that is that is injected into the prompt. So how somehow fine-tune or learn or teach the model just use better and more in a more efficient way the information that is fed into the prompt, and to search for those information. So to pay attention on the part of the prompt that contains the most valuable information to answer the question. Now I will speak about the OpenRAG scalability. As you see, I mean, going into production, scalability is extremely important. So basically, with our OpenRAG, we propose both vertical and horizontal scalability. How we achieved that? Simply, first, for the indexation part, we rely on the highly scalable array framework that can deploy the whole system or can run the indexation on the cluster. Second is the inference server. So to handle the load, both during indexation and during the chat phase, we, with our OpenRAG, we deploy the different inference server for different part of the pipeline. So we have a specific inference server based on the VLLM, which is quite famous inference server, open source, obviously, for the embedding and for the LLM or VLM generation. And for the re-ranker part, we found out that Infinity, it's a quite new framework, again, open source. It gives you a better throughput and it's much more effective. And last but not least, again, the bottleneck might be a vector store. So in our OpenRAG, we propose and we rely on the Milvus vector DB that is highly scalable and really production ready. Here is just the architecture of the overall system. So basically, at front, we have different APIs. We have the APIs for the search and indexation, and we also have the APIs for the chat. I will come to that later because we developed the chat API that are 100 compatible with OpenAI APIs. It is the integration of the RAG or OpenRAG into the production environment of your organization. And as you see here, basically everything is deployed, or we use a array cluster. So it might be deployed even on a single node. And that's why we achieve the vertical scalability, but also on multiple nodes, achieving the horizontal scalability. Now I will speak about the data privacy and security. So speaking about the data privacy, we propose the mechanism from Milvus. So it's called Milvus partitions. So basically, every user, once the OpenRAG is deployed, can store its own data into its own partition, so nobody else can access those data. So we do the segmented indexes by user and roles, and we can scope obviously retrieval mechanism. So you saw already in the demo But once again, I just put a screen shot here from our chat interface. You see, once you create multiple partitions, you have the partition that is called OpenRAG, let's say Linagora HR, Linagora Sales, or all team. And again, we can really segment it the indexes and give the fine-grained access across the organization for different partitions. Another point is the data security. And here we enhance the security. Basically, this is the work in progress, by the way. And so we gonna use the encryption in transit for the volume. So where the data is stored, we want to use AES 256 encryption algorithm. And we want to develop also the encryption at rest, because we want to encrypt the chunks that are stored in your vector store. So basically, how it's going to work. So obviously, we are not going to encrypt the semantic vectors, because we will lose the ability to do the semantic search. But we're going to encrypt the chunks right after embedding phase and before injecting into the vector store. And during the retrieval phase, obviously, we need to decrypt the chunks to feed the information into the LLM prompt. Another interesting feature of our OpenRAG is the ease of integration. So as I said, we developed the fully OpenAI compatible chat APIs. So here you have the like a snippet of the code source that shows how easy it is to use the OpenRAG just in the context of chatting. So you create your client, the OpenAI or async OpenAI client. Once you have the endpoint of your OpenRAG that was deployed, you feed the authentication keys and you are ready to go. You just chat as you chat with the standard endpoint of the LLM that is deployed and that is used across your organization. So switching from just chatting with the LLM that is deployed across the organization with the RAG that will give you more valuable information and that can use the information of the organization properly. Yeah, it's going to be really seamless and straightforward. So as you see, thanks to that, we achieved really like the seamless integration, developer-friendly and enterprise-ready solution. And last but not least, it's extremely easy to integrate our OpenRAG with the existing open source solution, like OpenWebUI, which is a very famous chat interface with the LLM models, or N8N for orchestration. So here I just put a few two screenshots. You see, you just put the information about the URL and the API keys, and then directly into the web UI chatbot, you can have the access to the partitions that that you can use to chat with. And for the N8N, you can use just the simple component that is compatible with OpenAI chat component. Maybe I don't know how much time do I have. Just, okay, so maybe the last thing that I would like to emphasize is this evaluation pipeline. So as I tried to explain at the very beginning of my talk, the evaluation is really challenging, and this is extremely important to run the RAG system in production. So basically, when we speak about the evaluation, what we would like to measure, we would like to measure the quality of the overall pipeline. So let's start with the first question. Does the model response align with the given context? Second question that we can ask ourselves while evaluating the overall pipeline is, did the model completely answer the user question? So as you see, there's a difference between those two questions, because even though the model gives you the somehow right or the answer, the answer might not be complete. So imagine that you are using the RAG, let's say, into the context of side effects of drugs, and you ask your system what are the side effects of a given drug. It's not enough that the system gives you just two maybe most dangerous side effects of your drug, just forgetting all the rest that are maybe minor, but it might it might concern you. So you see that that hoping or the system should completely answer the question. So should really list, in this case, the whole side effects of the drug. And there's also the part about the system optimization. So basically, we can ask the following question: do retrieved chunks attribute to the model's response, and how many? And second one, how much of the attributed chunks are used by the model? And those kind of questions are also very important. And basically, they will allow us to optimize the size of the chunk and maybe the number of chunks that we want to put or inject into the prompt, saving the tokens in production. So speaking about the metrics, basically for the quality metrics, you can think of the metrics that will measure the context alignment for the first, to answer the first question. For the second one, the metric that will measure the output completeness or comprehensiveness. And for optimization part, we might measure the chunk attribution and chunk utilization. And here at Linagora, while developing over our OpenRAG system, we also developed the evaluation pipeline. So basically, it's fully automated. You start with your samples of documents that are stored already, or they are indexed into your vector store. And then we want to create the evaluation data set fully automatically. So we apply the techniques that are widely used in topic modeling systems. So basically, we do the clustering, dimensionality reduction, HDB scan for clustering, and we sample uniformly from each cluster and use multiple chunks and feed them into the LLM to answer or to ask him for generating the query answer pairs. And we create the table or the data set of query, answer, and chunks. That is going to be used to do the automatic evaluation of the whole pipeline of the system. Once we have our data set, and as you see, you can run this with your own data or the samples of your data. We can run the actual evaluation pipeline using LLM as a judge. So basically, you have query, you have answers, you have chunk IDs. You use the LLM as an evaluation. You can gather the metrics that you think are most important to you and calculate the final score. And maybe to finish my presentation, I would like to speak about our next step and what we think of here at Linagora while developing the OpenRAG system, because our ambition is to be at the state of the art. So let's see what's go wrong. Assuming that you do everything right, and you create the really SOTA pipeline of your RAG, there are still some problems and drawbacks with the whole paradigm of RAG. So why? First of all, the problem is with in the part of search and the re-ranking, because while doing the search, you just take like the top K chunks that are semantically similar to the question asked by the user, and then you apply the re-ranker, and you also take the top K chunks, because you cannot put a lot into the context of your LLM. It's really depends on the context size of your LLM in the pipeline. So the problems and drawbacks are with basically with re-ranker. Why? Because even though you do the search and the re-ranking, LLM can still get a lot of irrelevant information. As you see, within one chunk, there might be information that are really relevant for the question, but there might be a lot of information that is not relevant. Second part, the drawbacks is obviously the top K chunks set to LLM context. So basically, it means that with this approach, the RAG approach, you can not really handle a lot of use cases that are really useful across the organization. Let's say you have in your system for your partition the HR human rights, human resources partition. You have all the CVs of your employees, and you would like to ask the question, let's say, give me the list of all employees that work for a given position. If you have a lot, if you're working for a big company, obviously just retrieving the top K, even though if the K is quite big, let's say 10 or 20, obviously you are not gonna get the right answer, because the system simply is not gonna retrieve all the CVs of people working for a similar position. And last but not least is also the problem with citation. So basically, what to give the also the kind of feedback to the user. This is what we implemented already in our OpenRAG system, that with the answer of the final answer of your LLM, you also quote, or you give the sources of the chunks that were used to answer the question. But the problem is that, as you see, if you retrieve the top 10 documents, but really the relevant ones are only 3, you're still gonna quote or cite the documents that are completely irrelevant in the answer of your system. So here at Linagora, we start thinking that even though everybody says that re-ranking is really crucial, and we agree that it's gonna boost the overall quality of your system, still there are problems and drawbacks with this approach, and we're gonna replace it soon with our approach that hopefully is gonna solve those problems. But this part is for maybe the next webinar. So I will stop here. I will invite you or I will call for contribution. So we'll have contributors. We hope that we're gonna develop the real open source RAG system that is gonna be state of the art and production ready. So here is our GitHub repo. It's under Linagora OpenRAG. So if you have any question, you can also communicate with us with the issues and start playing with our OpenRAG. So maybe sorry. Maybe now I would like to give a mic to one of my colleagues that is also developed the solution. It will give you like a short walk through the repo so that you can maybe better understand the overall repo and the architecture in case you want to simply play with our OpenRAG or maybe even collaborate. Thank you.
Okay. Thank you, Andrzej, for the presentation. Now I'm going to walk you through the repository in order to contribute into our project and to better understand our architecture, but also to ease you into contributing. First of all, well, easily you can README. The README file is actually your friend. You can go through the README to better understand our project and better understand actually our current features and where we are going. From the README file, sometimes we reference a different part of our documentation. For example, if you want to deploy your application in a cluster of machines, you can go to like the docs file, and you can find like there's a deploy RAG cluster file that actually gives you detailed instructions in order to deploy RAG in a cluster of machines in order to scale your RAG application. I'm going to go through the configuration of our project. We use actually Hydra. Hydra actually is a powerful framework developed by Facebook in order to manage configuration. For example, in our setting, we have like a very complicated setting, and so Hydra is actually very powerful for that. So we have like here in the same file different configurations for different part of our application, for example, for the vector database or for the embedder. And yeah, the configuration can be overwritten from your .env file. So that is basically the config file, and when loaded, it's actually like a nested dictionary, and you can easily access to different part of your configuration. So that's basically the configuration file. Now let's go into the most important aspect of this presentation. It is actually this OpenRAG folder. Inside it, you have like the components folder. So as you know it, in RAG, we have like two components. We have like the indexation pipeline, where you serialize your documents and then you chunk it and then you insert it into your vector database. So in this folder, we have like different loaders, so different serializers. You can inherit, you can add like a new serializer, inheriting from our base one and implementing relevant methods. So that is basically the serialized, our loaders. We have also chunkers, different chunkers. Again, you can create like a new chunker and inherit from our base one. And finally, we have vector database. Same story. You just have to create a new vector database and implement methods, abstract methods. So basically that is the indexation pipeline. Now we have the RAG pipeline. So as you know it in RAG, you have like to retrieve documents. So we have like a retriever file that handles different type of retrievals. You can also add new ones and implement again. We have re-rankers to re-rank documents, and we have basically this file that composes all of those files to prepare the answer. So as you know it in RAG, you have to retrieve the document. You have to have, you have your query, you retrieve documents, you format it, you give it to your LLM, and then you get the answer. So that's basically the RAG pipeline. Now I'm going to talk about a little bit this folder, extend folder. In this folder, we have different YAML files, Docker files actually, for different services of our application. For example, for the LLM, we have like a folder for it. Same for the re-ranker using Infinity, and same for Chainlit and Indexer UI. I'm going to present you quickly the API. So it's very easy to understand and well organized. So this is the API. You have the Indexer API. It is a RESTful API. And actually, we did develop an interface to ease partition management. For example, this is actually that interface. In order to create new partition, you can create like here a new partition, and you can upload your files here easily. And yes, the pipeline will run behind and inject those files. We have also different endpoints like semantic search, the partition and files endpoints, and the queue management, and finally the OpenAI compatible API, which is actually the most important, one of the most important features of our application. And so, as I said it already, our indexer UI actually interfaces with these endpoints in order to ease indexation and manage your partitions. And as presented before, we have Chainlit for, it is like a chat interface. And from Chainlit, you can list you can choose a specific partition and again chat with it. Still through the repo, we have finally prompts. As you know, prompts actually are very important in RAG settings. So you can also add new prompts and overwrite and experiment different kind of prompts. So that's it basically. For vector DBs, maybe I can add something about it. We have Milvus, the setting for Milvus, basically, and Quadrant. If you want to add the new databases, you can do that as well. So as you know, this is actually a project that is still under development. You can, we encourage you to read the README, to experiment with the project, and feel free to ask the questions and suggest new features and help us actually improve our project. You can start by giving us more stars as the first step, and create new pull request to contribute to our project. Thank you very much.
Thank you, Ahmad, for this walk through our repo. So again, we are delighted, and we call with this webinar for the contribution and support of of our OpenRAG. Now I think there's the final part of this webinar is the question. So do not hesitate. You can either ask the question now loudly, or you can chat or put in a chat, and we will try to answer those. Thank you very much. Okay, so Paul asked the question, maybe some insights on the solution that we are working for a better relevance of sources. So basically, our idea, it's a kind of research project that we start thinking or developing, is replace re-ranker with the mechanism that is widely used in the summarization approach, automatic summarization approach, which is called map and reduce. But more on that, I think maybe we can organize another webinar like in September, and we will give you more details. So stay tuned. Yeah, I see another question. Is it possible to deploy OpenRAG with CPU? Yes, it is. We have the, yeah, you can see in our documentation that it is possible to run it in the CPU. Obviously, it's not a recommended way because the solution was developed with the scalability in mind. But yeah, to try, you can run. Again, you might need quite powerful CPU and a lot of memory to be able to use it in a reasonable time. Yeah, speaking about the security of data, yes, we do the index partitioning, but also we have we started developing the encryption. So the data that is gonna be stored, so the volume of for the vector DB is gonna be encrypted. We gonna have also the encryption in transit and at rest. So it means that while the data transit across the cluster, it's gonna be encrypted, and at rest. So this is what I explained. We're gonna develop the solution that is gonna encrypt the chunks before injecting them into the vector DB, and decrypt on the way back, so during the retrieval phase. Okay, which part of the pipeline needs GPU execution? So basically, yeah, as you see in the pipeline, you have a lot of models, the deep learning models that are used. So basically, is the embedding, so embedder that calculates the semantic vectors of your chunks. The re-ranker, it's another deep learning model, and obviously the LLM or VLM, so visual language models that are used for image captioning, or the systems like OCR models, and the LLM as an endpoint for your chat. So as you see, there's a lot of requirements for GPU in the overall pipeline, but this is how RAG works. Thank you very much again for your time, and hope seeing you soon. Thanks again. Bye.